Hello, math analyzers, and welcome to your Chapter 9, Lesson 2 notes, all about rotations and angle terminology. All right, so let's start with a real basic review of the coordinate plane. So you remember the coordinate plane, the XY axes, it's taking two number lines, a horizontal number line that we know as the x-axis, and a vertical number line that we know as the y-axis, and it places these two number lines together at right angles at their zeros. And then what that does is that creates all these integer coordinates that we see on our grid points, right? That we see as grid points. All right. This divides the grid into four quadrants. Quadrant 1 starts here and where everything is positive. Quadrant 2, then we go to the left. I know, not the way we read, but that's all right. We go to the left for quadrant 2, where the y's are still positive, but now your x values are negative. Down in quadrant 3, everyone is negative. And then back to quadrant 4, where y's stay negative, but x's go back to being positive. Okay, so the four sections, of course, 0, 0 is your origin, y-axis, x-axis. So now let's talk about angles. The terminology, I mean vocab, right? The vocabulary that I'm going to use when I talk about angles in my coordinate plane. So when I talk about an angle in the coordinate plane, the initial side is always this side right here with the x-axis. From this start, the terminal side is where the angle ends. If I head from quadrant 1 to quadrant 2, 3, 4 like this is a positive angle measure. Okay, and this is known as your angle in standard position. All right. So standard position, an angle is said to be drawn in standard position if its vertex is at the origin, vertex, and its initial ray points along the positive axis. This guy, starting with the positive x-axis. That's your initial side. Here's your standard position. Again, positive rotations counterclockwise, this direction. Okay. Negative rotations are an angle that is in standard position, but it goes from its positive x side and measures down clockwise. So if you're measuring clockwise, that's a negative angle. If you're measuring counterclockwise, that's a positive angle. So notice I could have found the positive version of this going this way. See that? So I could have gone that direction. Okay. So some vocab we need. Quadrantal angles. I know that's how you say it. It seems like such a weird word. They have their terminal side on an axis. So they're the 90 degree, the 180 degree, the 270, the 360. 360 and 0 being technically the same, right? Coterminal means it's two angles drawn in standard position that share a terminal ray. One of them is positive and one of them is negative. So that means they both have their initial side being the positive x-axis. The one you draw counterclockwise is your positive. The one you draw clockwise is the negative. These guys are coterminal. Essentially, absolute value-wise, they'd add up to 360 degrees. They'd add up to the full circle. Okay, that's coterminal angles, sharing their end ray. Okay? Now, what is that really going to do for us? When we start to look at the unit circle, we are going to use some very specific angles as reference because they are angles where we know, based on our work with their sides and their angle measures, we will know their exact values for the length on x and y, meaning we can have their exact coordinates on the circle. Okay, that's why we call them reference angles, because they reference work we've previously done in chapter 8 with our special right triangles. It's really neat how that will come together with our circle. Okay, so reference angles are a positive acute angle formed by the terminal ray and the x-axis. Each quadrant has a reference angle, okay, that will look a certain way. So quadrant 1's reference angle is itself, okay, because it is in quadrant 1 and we start from quadrant 1. Quadrant 2's reference angle will be right here. From here to here is its reference angle. I want to know this degree measure right here. That will help me understand my coordinates. Here, the reference angle, it's always from the x-axis. Here to here is the reference angle. Okay, it always heads back to the x-axis. And then from here to here is the reference angle. So essentially what it looks like, and this is what my teacher used to draw, and I really didn't understand it until I started teaching it myself and said, oh, yeah, the bow tie, right? If this is a sketch of my coordinate plane, reference angles are these angles. They look kind of like a bow tie. And they're always, with the exception of this one right here, they're always this measurement heading back toward the x-axis, right? I mean, technically this would be heading back towards the x-axis and knowing, okay, how many degrees would get me to 180? If this is my full angle measure, what's this degree right here that gets me down to that axis? So these are the areas you find the reference angles. We'll do a lot of practice with that too and use the terminology and put it all together right here in the application. Okay, what does this all mean for questions we may have to answer? Well, I'm going to give you an angle in standard position. Here it is, 150 degrees. This angle is in standard position because here's my terminal side, here's my initial side, the positive x-axis, okay? What I look for first is coterminal angle. So if this one is counterclockwise, so it's a positive degree. If I went back this direction and did my negative, what is the degree of this angle? Coterminal, sharing, right? Well, we said that the coterminal angles their absolute values will add up to 360, right? So if I take 360 and I subtract the angle measure I already know, which is my 150, the absolute value of that, right? I get 210. That means because I'm going this direction, this is a negative 210 degree angle, okay? Because I'm going clockwise with it. So again, there we are. It says between 0 and we're going the negative direction, so I'm still going to include that negative sign. What is the measure of the reference angle? So like I said, the reference angle is what right here gets us down to the x-axis, right? So, okay, from 150 and a little bit more, that gets me to a total of 180 degrees, right? That straight line. So right here, I just take 180 and subtract the 150. I'm sure you can do that in your head, but just showing you how this works, right? To get the reference angle is 30 degrees right in here. And that's going to be the angle that we kind of use, the angle in question we use, because we know how the proportions of the sides in a 30-60 angle, a 30-60-90 right triangle work. So this will be really helpful for us figuring out the coordinate points. That one was just those two questions, but let's do another one. This time, this angle starts negative because we're going clockwise from the terminal side. So if I want to know its coterminal angle, this is when I go counterclockwise. Okay, so I go counterclockwise, take the absolute value of this and subtract it from 360. So 360 minus 135. And again, I say absolute value because their absolute values are what add up to 360. That means this is a 225-degree angle, okay? Notice I'm labeling my picture and answering the question part, okay, so that I'm showing you back and forth how this all comes together. What's the measure of the reference angle? Well, here's the terminal side down here, so I need to go back up to the x-axis, okay? That's the reference angle in here. So I'm going back up to this 180, right? So there's two ways that I could look at this. I could say, well, if I took the absolute value of this and subtracted it from 180, so 180 minus 135, 135, gives me a reference angle of 45 degrees in here. Or I could say, well, I know my full angle is 225. If I take that and subtract 180, I get back to the x-axis. So either way, I get that my reference angle is 45 degrees. And again, we know the proportions of the sides in a 45, 45, 90 right triangle. That's why that's important for us to know. We're going to use that angle to help us with the sides by creating right triangles. It's going to be pretty neat. What is the radian measure of the original angle? Well, we need to convert 225, negative 135 into radians. And since negative 135 is already in degrees, that's how I know that I multiply by pi over 180, because I need there to be a pi in my answer because I'm going to radians, right? So essentially what I type into my graphing calculator is my negative 135 divided by 180 and see what it comes up with. Okay, that's actually something that we could probably do in our heads, but if it's not a fraction you can, or a decimal that you can convert to a fraction in your head, you go math, fraction, and we convert it to negative 3 pi over 4. So see, when I type in my graphing calculator, I leave the pi out of it. So I just look at what the numbers are doing, and I add the pi at the end. So I get the simplest form of the fraction used here. So negative 3 pi over 4. What is the radian measure of the reference angle? Same thing. I know the degree measure of the reference angle is 45 degrees, so I multiply that by pi over 180. Okay, so I know that I'm multiplying by pi over 180 because I know since I'm going to radians, I need to have a pi on the top. Okay, radian measures, they'll typically be these fractions with pi involved. So now I take just the numbers 45 and divided by 180, and I get 0.25. Again, easy to convert because we know that decimal conversion to a fraction, but just in case, math, fraction, enter 1/4 or pi over 4. That will be one of the ones you end up memorizing because you're going to use it so much. So pi over 4 is the radian measure of this reference angle that is known as 45 degrees. Last one, what is the radian measure of the coterminal angle? Okay, the coterminal angle was 225. So again, because I'm converting to radians, I multiply that by pi over 180. Okay, and in my graphing calculator, I do 225 divided by 180. And I'll add the pi after I get the fraction in simplest form, which ends up being 5 over 4. So 5 pi over 4 is the radian measure of that coterminal angle. So understanding what angle I'm talking about, using the vocabulary correctly, and then being able to convert from degrees into radians, or like in the next one, from radians to degrees. So I this time gave you the angle measure in radian form. So now what I'm going to do is I'm going to go back and forth and convert, okay? Now, I actually think, because I'm a degree person and I think you're probably degree people, that maybe converting would be the smartest thing to do, converting that right off the bat, and then I can go back and forth that way, okay? So because I know I've got radian measure and I've already got a pi, if I want to convert this into degrees, this time I multiply by 180 divided by pi. And what that does here is it cancels the pi's out. So now you have 28 times 180 divided by 18. 29 times 180 divided by 18. So 29 times 180 and then divided by 18. Which, by the way, could have just divided 180 by 18 and I'm left with 10. And what's 29 times 10? 290. Just trying to give you some hints. So I know that my angle measure is 290 degrees, okay? So the degree of the original angle, 290 degrees, okay? The coterminal means that it matches right here, okay? So actually, why don't I use my 290 and subtract it from 360 to get that coterminal in degree form, 70 degrees. Right here. And then let's convert back to radians, right? So since I know I have 70 degrees, this is when I multiply by pi over 180 because I need there to be a pi up in the numerator. So really what I plug into my graphing calculator is the 70 divided by 180. Get that fraction in simplest form. So since that's a, repeated decimal, I do this. Oh, I get 7 over 18, which is 7 pi over 18 for the radians. That's your coterminal, okay? So from here to here is 7 pi over 18. And if I think about that, 29 plus 7 is 36, right? So 360 pi over 18 divides to 2 pi, and that's a full circle in radians. So it makes sense. So I really could have done that subtraction very easily with radian form as well, but I'm just showing you, who is probably more a degree-minded human, how to do that in the degree form. Oh, the coterminal angle and the reference angle are the same, aren't they? Because look, this is the angle that heads me back to the x-axis from the terminal side. So that is also the degree measure of my reference angle, or the radian measure of my reference angle. Isn't that cool? How that works? There you are. So that's what I'm asking you to do on your homework. Okay, and go back and forth. It really is all about the terminology, what I'm asking you to do. So do make sure you understand standard position, that going counterclockwise is the direction you go for a positive angle in standard form, and going clockwise is the direction you go for the negative angle in standard form. And then understanding the reference angles right here. Okay, which ones are the reference angles? And so what I mean by that. And then, of course, using our first lesson about converting radians to degrees and degrees in radians. So already putting a few of these pieces together to get us ready for that big piece, the whole unit circle together, right? Okay, math analyzers, this has been your Chapter 9, Lesson 2 notes. Let me know if you need any help. Good luck and have some fun with this. Bye.